So today we will be seeing about measurement of small distances, and the first instrument that we are going to see is screw gauge. So screw gauge is an instrument used for measuring accurately the dimensions of objects up to a maximum of 50 millimeter. So in this, the principle of this instrument is magnification of the linear motion using a circular motion of a screw. So this is the portion which is going to move linearly, that is left and right, and this is the part of the screw gauge which is going to make a circular motion. Okay. Now the terms which you have to know in this part is there is a term called pitch. Pitch is the distance moved by the screw divided by number of rotations. So pitch is the distance moved by the screw divided by number of rotations. Distance moved by the screw, that is, suppose you have to move 3 millimeter in the 3 millimeter, okay, and the thing is how many rotations you have to make in order to move 3 millimeter, that is 6 rotations. 6 rotations. So which comes to 1 by 2, that is 0.5 millimeter. So the pitch is 0. What this means is, so suppose you have to make a 0.5 millimeter, you have to make one rotation. In order to you have to move the screw by the number of rotations you have to move is one rotation. So that is, if you have to move 0.5 mm, you have to make one rotation. In order to, if you have to move the screw by 1 millimeter, you have to make 2 rotations. So that's what it means, pitch. Okay. So suppose you have to move this by 1 millimeter, you have to move this, the number of rotations you have to make is 2 rotations. Suppose you have to move this by 0.5 millimeter, you have to make 1 rotation. That's what this pitch means. Okay. Now there is another term which you have to know, that is called as the least count. The least count is a pitch by least count formula is pitch divided by number of circular scale divisions. Number of circular scale divisions. Okay. So pitch, we all know, we got 0.5 millimeter. Okay. Number of circular scale divisions is 50. That is, if you are making, that is for one rotation, it is divided into 50 divisions. Okay. That is, when you make a rotation, a rotation of complete rotation of one rotation, you move it by 0.5 mm. So in that one rotation, there are 50 divisions. That's what it means. So the value is 0.01 millimeter, which is also can be written as 0.001 centimeter. So this is the least count of screw gauge. Okay. Now I hope this is clear. Pitch is the 0.5 mm, which we already obtained, and the number of circular scale divisions, that is 50 divisions. What this means is, in order to make a movement of 0.5 mm, we have to move it by 50 divisions, that is, we have to make nearly one rotation. So the least count of screw gauge is the minimum amount of measurement that can be taken using the screw gauge. So the least measurement that can be taken. Suppose if you take a scale of say 30 centimeter or 15 centimeter scale, the maximum measurement that can be taken, okay, in a scale which we use in a daily school life, where it will be 15 centimeter, right? 15 centimeter. So the maximum measurement that can be taken is 15 centimeter. The minimum measurement that can be taken is 1 millimeter. Similarly, for the screw gauge, the minimum measurement that can be taken is 0.01 millimeter. Okay. Now we will go back to screw gauge. Sorry, Vernier calipers. Now we go back to Vernier calipers. The Vernier calipers is an instrument for measuring the dimensions of an object, namely the diameter of the hole or depth of the hole. The least count of the Vernier caliper is 0.1 mm. So here you will be able to observe that the Vernier caliper, the least count is 0.1 millimeter. Okay, so the compared to screw gauge and Vernier caliper, screw gauge measures objects of even smaller screw gauge measures objects. Screw gauge measures very small objects compared to Vernier caliper. So the least count of the Vernier caliper is the least count of Vernier caliper is smallest reading in the main scale. Smallest reading in the main scale. Smallest reading in the main scale divided by number of divisions in the Vernier scale. Number of divisions in the Vernier scale. When we are saying main scale, I am talking about this. This is the main scale. When I am talking about the Vernier scale, this is this portion. Okay, this is the Vernier scale. So, in order to suppose we will take an example. So now the least count, the smallest reading in the main scale is, say for example, 1 millimeter, and the number of divisions in the Vernier scale is 10 divisions. So when you have to move 1 millimeter here, you have to 1 millimeter here is divided into 10 divisions. That's what it means. Okay. The value is 0.1 millimeter, which can otherwise be written as 0.01 centimeter. So next we will go to the measurement of larger distance. We have seen the measurement of smaller distances of up to 0.01 millimeter. Now suppose we have to measure larger distances such as the height of a tree or distance of the moon, etc. What we have to do? That's the thing here. That's a method for measuring the larger distances. The method is called the triangulation method. That method is called the triangulation method. Triangulation method. Here we take an example of, let A be, observe this diagram. Okay, A, B and C. Okay, A, B and C. AB is equal to height H. This is the height of a tree or a tower to be measured. Let C is the point of observation from which we observe the tree. So from C we have to estimate the angle from which we are observing the top of the tower or top of a tree. So we have to measure the angle. So only with the help of the measurement of an angle we will be able to find out the height of the object or height of the tree. So for this we have to use the trigonometry using the right angle triangle ABC, we know that tan theta is equal to, we know that tan theta is, what is the tan theta formula? Opposite side by tan theta is equal to opposite side by adjacent side. Adjacent side. What is the opposite side here? Opposite side of this angle AB. What is the adjacent side? BC. So this is the opposite side here. Okay. The opposite side of this angle is this portion. This is the adjacent side. So that's what they have written here as tan theta is equal to opposite side H divided by adjacent side X. So the height H is equal to X tan theta. So when we are bringing it here, H is equal to X tan theta. And suppose we are assuming that, so they have given a small problem. Suppose the height is the angle from a point on the ground, the top of the tree is seen to have an angle of elevation 60 degree. The distance between the tree and the point is 50 meter. They have given the value, this distance as 50 meter. This distance is 50 meter and this angle as 60 degree for this problem, and the distance is, so H is equal to X tan theta, 50 into tan theta is 15 to 1.732, that is H is equal to 86.6. So from this we measure the height of the tree is 86.6 meters. I think this will be very clear for you. Next we will see a method called parallax method. So the method which you have seen for measuring of heights, smaller heights, okay, like tree or a tower, we are using an angle. That the method used is called triangulation method. Now we will use a method called parallax method. Parallax method is used for measuring very large distances. Very large distances, such distances like a planet or a star, distance a star from the earth can be measured using parallax method. Parallax is the name given to the apparent change in the position of object with respect to the background. And the object is seen from two different positions. The distance between the two positions is called basis. So now we will see what this is. The observer is holding a pen. Observer is holding a pen before him against the backdrop of wall. When the pen is looked at first by our left eye L, closing the right eye, then by our right eye or closing the left eye, the position of the pen changes with respect to the background of the wall. This shift in position of an object, that is the pen here, when viewed with two eyes, keeping an eye closed at a time, is known as parallax. I think you can just make an experiment of it. Okay, this is very clear. This same concept is used as a basis for measuring the distances of distance between the earth and the moon, or between the earth and the planets, etc. Now we will see how it is used. Okay, LO, observe this, here it is L, here it is O, here it is R. Okay, this is, suppose if this is the distance, suppose if this is moon, O is moon, suppose we keep this as moon. Okay, moon, and here we are observing here, we are standing here, and this is the left eye. Okay, this is the, we are observing here from the left eye, we are observing here from the left eye. This is the right eye, we are standing here. Okay, suppose we are standing here and we are closing the right eye and we are seeing from the left eye. So what is the distance? Okay, what is the angle? What's the angle? And we are seeing from the right eye, closing the left eye, and we are seeing what is the angle. We get an angle. So that angle is, we take it as theta. That theta is equal to B by X. X is the unknown distance. X is the unknown distance. Then knowing B and measuring theta, we can calculate X. Determine the distance of the moon from the earth. In figure 1.5, C is the center of the earth. A and B are two dimensionally opposite. C is the center of the earth. This is the, here we take it as C is the center of the earth. This is the earth. This is the moon. Okay. A and B are two diametrically opposite places on the surface of the earth. From A and B, the parallaxes theta1, theta2 respectively of the moon with respect to the some distance star are determined with the help of an astronomical telescope. This is the total parallax of the moon. Subtended on the earth is A and B theta1 plus theta2. See, from A and B, the parallaxes theta1, theta2 of the moon with respect to some distant star are determined with the help of a. Okay, now observe this. We have a moon here. We have a earth here. This is the center of the earth. Forget about all this S1, S2 and all that. Now we are observing, we are going to use the same formula like here. We are going to observe this, measure the distance between the moon and the earth. So we will see how this is being measured. You remember the formula, theta is equal to B by X. Theta is equal to B by X. We have to measure the X. That is the distance between the moon and the earth. Okay. We are using the same formula. That is theta is equal to B by X. We are writing X is equal to B by theta. What is B? B is that is the radius of the earth. That is diameter. That is diameter. B is the diameter of the earth. That is the diameter of the earth is 2 into 10 6.4 10 to the power 6. That is the diameter of the earth, and theta is the angle, the angle of observation. Okay, that is the angle here which we observe based on the left eye and right eye. By closing the left eye and right eye, we get an angle. So that is the angle here. So that is theta. That is 1.55 minutes, 1 degree 55 minutes, which can be written as 115 minutes. Which in terms of seconds, when you are writing 115 into 60 seconds, and when we are writing as seconds, it should be written as 4.85. 1 second is 4.85 in 10 to the power minus 6 radian. So we are writing as 115 into 60 seconds into 4.85 in 10 to the power 6 radian. That is totally, when we multiply, we get 3.34 into 10 to the power minus 2 radian. So when we totally calculate, we get a distance of X is equal to B, that is the diameter of the earth, divided by the angle which we got by parallax method, and finally the X is equal to 3.83 into 10 to the power 83 meter. So that is the distance between that is the distance between the X. This is the X we are talking about, the distance between the moon and the earth. Then the radar method. The word radar stands for radio detection and ranging. A radar can be used to measure accurately the distance of a nearby planet such as Mars. In this method, radio waves are sent from transmitters which, after reflection from the planet, are detected by the receiver. By measuring the time interval between the instants the radio waves are sent and received, the distance of the planet can be determined. The distance of the planet can be determined as, we all know that velocity is equal to, what is the formula for velocity? Velocity is equal to distance by distance. Velocity is equal to distance by time. Distance here when we are saying there are two objects, say we are from the earth, okay, we are from the earth, here it is moon, we are sending the radio waves from the earth from here, okay. So this is the distance x, and after reaching here in, say for example 1 hour, say for example 1 hour, and again the radio waves have to come back, so it will take some distance, that is distance x, that will take some 1 hour. So the total distance covered here is not just x, so it is 2x. So that's why it is a 2 will be added here when we are measuring distances, that is 2d, okay. 2d, velocity is equal to distance, that is 2d, we can take it as d, okay, distance according to the value here 2d, and the time taken. So when we have to measure d is equal to velocity into time divided by 2. We are just rearranging this, okay. Into t. Now when we have to measure distances, we are taking this t here, we are taking this t here to this side, and we are d equal to v into t divided by 2. V is the speed of the radio wave, as the time taken t is for the distance covered during the forward and backward path of the radio waves. It is divided by 2 to get the actual distance of the object. This can also be used to determine the height at which the aeroplane flies from the ground. In the army, radar, there is a separate division called radar division, which is used to find out the distance. Suppose if the aeroplane from an enemy country comes into our territory, we will be able to find out the distance of the plane from the ground, okay, using by sending the radio waves here from our radar equipments. So this is the method used. Radar signal is beamed towards a planet and its echo is received 7 minutes later. If the distance between the planet and the earth is 6.3 × 10 to the power 10 meter, calculate the speed of the signal. So here they are asking to find the velocity. In this problem, the distance of the planet is, so v is equal to, same formula, velocity is equal to distance by time, that is 2d by t. Here distance is, they have given, time taken is 7 minutes, we are converting it into seconds, that is 7 into 60. So finally we are getting 3 by dividing 3 × 10 to the power 8 meter per second. So here the distance we are having it in meter, we are having this distance in meter, and this the distance 7 minutes is converted into seconds, meter per second. So we are getting the velocity unit as meter per second. That is written as ms to the power -1. So that is the speed at which the signal is being sent for the in order to find out the distance of the planet from the earth. So here they have given distance of the range and order of length, size of the object and distances and the length, distance to the boundary of observable universe. So they are given the distance of various distance of the earth from the nearest star, average radius of the Pluto's orbit, and all these things they have given. And also they have given some common practical units which will be using regularly, like Fermi, angstrom, nanometer, micron, light year, the distance traveled by light in vacuum in 1 year. All these things, you just go through it, we'll be using it at a later stage. Chagrin limit is the largest practical unit of mass. So 1 CSL, Chagrin limit, is equal to 1.5 times the mass of the sun. The smallest practical unit of time is shake. S-H-A-K is shake. One shake is equal to 10 to the power minus 8 seconds. So remember these two things. This has been given in a box. This is the largest practical unit of mass. This is the smallest unit of time. So the measurement of mass. Now we will see the measurement of mass. Mass is a property of matter. It does not depend on temperature, pressure, and location of the body in space. The mass of a body is defined as the quantity of matter contained in a body. The SI unit of mass is kilogram. The mass of an object which we study in this course vary over a wide range. This may be from a tiny mass of electron to huge mass of universe. So there's a range, okay, from small mass to a larger mass. See, this is the smallest mass, this is the largest mass. So this is the range in range of masses. The order of mass of various subjects is given here. Ordinarily the mass of an object determined in kilogram using a common balance like the one used in the grocery shop. For measuring larger masses, so we all know we measure, when we go to a shop, we measure, we buy various things like rice or vegetables, and we measure it using kg. But for measuring the weight of an object like earth or a moon or very small objects like electron and proton, we need different methods. So different methods are being followed. So that's what we are going to see that also here. For measurement of small masses, for measuring larger masses like planets, stars, we make use of a method called gravitational method. For measurement of small masses, we make use of a method called mass spectrograph. Some of the weighing balances commonly used are spring balances, electronic balances, which you see in the common everyday shops here. Measurement of time intervals. A clock is used to measure the time interval. An atomic standard of time is based on the periodic vibration produced in a cesium atom. When we are saying time, there are some certain times which we can measure easily, like a clock or running race, going in a running race, or the time taken to walk 100 meters or 200 meters, a kilometer, etc. There are various other events that for which we have to measure time, like finding out the travel time of light from sun to earth, time period of a satellite, okay, age of the universe. There are various methods are being used in order to find out this. So you can just go through it and remember some of this. I think we will be seeing in detail about this later. Theory of errors. The foundation of all science and technology is measurement. The results obtained from any measuring instrument will contain some uncertainty. Such uncertainty is termed as error. Okay. Any calculation made using the measured value will also have an error. It is not possible to make exact measurement in an instrument. In measurement, two different terms, accuracy and precision, are used. And need to be distinguished at this stage. Accuracy refers to how far we are from the true value. Precision refers to how well we measure. Remember these two, accuracy and precision. Okay. You know the true height is exactly, let us say you know the true height is 5.9. You first measure your height with the yardstick and get a value of 5. Your measurement hence is not accurate. Now you can measure your height with a lesser yardstick and get 5.9 as the value. Now your measurement is accurate. So you will be able to understand this better with another example. Let us see that. Before seeing that, if a measurement is precise, that does not necessarily mean that it is accurate. However, if the measurement is consistently accurate, it is also precise. We will see this. You will be able to understand that better with the help of this experiment. Suppose you consider this as a shooting spot, okay, shooting place where we have to shoot at this bullseye, okay, red portion, and we are shooting with the help of a gun. Okay. Now in that case, when a person shoots this target, this is the target, okay, and this is the various locations in which he hits this target from the first time, second time, third time, and fourth time. We say it is not accurate and not precise. Here you observe it is not accurate, precise. Here, okay, here it is accurate and precise. We will see one more scenario, accurate and not precise. I think that portion, I think that thing is missing here, accurate and not precise. Consider this portion as the red portion. Okay, that's consider this as a red portion. Consider this like a red thing here, and then you have a, when a person shoots, when he exactly shoots here, for example, when he exactly shoots here in this portion, it is said to be accurate, and here when he consistently shoots the same place, okay, when he consistently shoots all the four in the same place, it is also said as precise. It is also said as precise. Okay, here he shoots here, but he shoots consistently in one region, which is only when he shoots around this area it is called as accurate. Okay, only when he shoots around this area or exactly within this area it is exactly accurate. But here in this case he shoots far away from this accurate position, but within this position he is shooting consistently within this area, not as bad as this area, not as bad as this. So he has improved from here to here. He has some consistency, but he is not close to the target. So when you are close to the target, it is called as accurate. When you are away from the target, but you are close within the range, it is called as precise. Okay, precise. Here it is just close to the target, and also it is this portion, this also is very close. Okay, very close and consistent. Here in this case the target is red, whereas it is closer to the target, but these values are not consistent or close enough. Okay, this here, say for example 5 centimeter, here it is 5 centimeter, here it is 5 centimeter, this is 5 centimeter, 5 centimeter, but it is in the, but there is no closeness among this portion. So only when there is closeness among the first attempt, second attempt, third attempt, it will be called as precise. When there is no consistency in the attempts, when there is no consistency in the attempts, it will be called as not precise. It will be called as not precise. But still it is called as accurate because it is closer to the target. So I hope you will be able to understand this.